Okay, let's discuss the next problem. A thread is usually defined as a lightweight process because an operating system maintains smaller data structures for a thread than for a process. Okay, so a thread is, a process is composed of many threads. Okay, uh, data structures for thread are smaller because a process has many threads, and all of these threads use the same code of the process, they use the same files, they use the same memory of the process. Okay, and that's why they are light, because they don't have their own files, they don't have their own code. Okay, the code they run is part of the process, they don't have separate codes. Okay, all of them, they run the same code, that is the process code. But what they do have certain things that are their own. Okay, and that's what's discussed in this problem. In relation to this, which of the following is true? On per thread basis, the operating system maintains only CPU register state. So what is CPU register state? So you have all these CPU registers. Okay, so if some process is running or some thread is running, okay, so there are certain values in these CPU register states. All what are the operations going on? Okay, the stack pointer to the stack, and those condition code flags and all these things are in the CPU register. So, and these things will vary from thread to thread because a thread is running, so it will obviously change the CPU register state. So this thing varies from thread to thread, that is true. Okay, and the operating systems for a particular thread maintains CPU register, that is also true. But when they say that only this thing, then it is not true, because what happens is that along with this CPU register state, a thread also maintains a stack. Okay, so a thread has is its own stack. A thread has its own stack. A thread has its own registers, like these CPU register states. It has, all of these are different for all these threads. Okay, so if there was no only, this would be true, but there's this only thing and we don't see stack out here, so that means that this is not true. Okay, OS does not maintain a separate stack for each thread, and this is definitely false, because we just discussed this thing. A thread has its own stack because it has to do all those operations. Okay, it has to call, it might do some function calls, and all those things will go on top of stack, so it does need its own stack. So this has to be false. On per thread basis, the OS does not maintain a virtual memory state. Okay, so what about this thing? It doesn't maintain virtual memory state because it's maintained on per process basis. Okay, for this process basis, for all processes you have these base and limit registers, which gives your virtual memory mapping to your physical, which provides this limit on which this limit of memory regions. Okay, this region of memory that is allocated to that process. So this is not done on per thread basis. Okay, so that is true, that means this thing is true, and which means this option C is correct. Okay, and you can see that, okay, this D is definitely not true. Okay, because it's obvious it's not true. So yeah, that's true.